Hi, D. Dykstra here, doing another quick math calculus video for you, optimization. This is a fencing problem. So let's take a look here what we have. We have a rancher, if I can get it focused here, rancher who wants to build a fence that has two equal rectangular areas next to each other, all right? Adjacent to each other. So what we do is we draw a picture, right? Here's what the picture looks like. Here's our two rectangular areas that are enclosed by some fencing. And what that's going to do is that's going to break up this area as an X because it's equal. This X will be the same. And I also have an X here and an X there, right? All these X lengths are the same. And when we build the Y values, we'll build here, and so I have 3 Y's. So when I look at my area, I have an area equal to 2X times Y. Now in some cases we might just call this X, but for the purposes of this video and this particular problem, I like to attack it with a 2X, okay? Now, another part of this problem is a second equation. And for that, we go to this information. It says the rancher is using a total amount of fencing material used was 1,200 yards. What is the maximum area? So we're given a total amount of fencing, and then in our case, what we have to do is find the maximum area. Okay, so here we go. Let's go back. Perimeter. Well, that's 4x. Remember, perimeter is just adding up all the sides. And the lengths. So we've got 4x plus 3y. That's our perimeter. And the area is what we want to maximize. So that is what's to be maximized. All right, so now we look. And first thing we got to do is, again, we want to eliminate one of the constraints and get it into an x value or a y value that we can substitute into another equation and solve. So since I've got perimeter information here, I'm going to use perimeter. If it gave me a volume, then I would use the volume equation and then substitute that into a perimeter to maximize or minimize. In this case, we've got perimeter information. So 1,200 is equal to 4x plus 3y. 1,200, we subtract the 4x, so 1,200 is minus 4x now, is equal to 3y. Divide by 3, and we get 1,200 divided by 3 minus 4x divided by 3. And if I reduce that, that gives me 400 minus 4x is equal to y. All right, moving along. Well, now we have it in terms of y. So what we're going to do is, because we want maximum area, we're now going to substitute that information into our area. So we have 2x times the 400 minus 4x over 3. That's our y value from before. All right. So now what we can do is we can simply take that area and distribute this 2x. So now, because there's no power here, I can go ahead and distribute this 2x there and there. And what that'll do is that's going to give me 800x minus 8x squared. And then now my area is ready to be, we can now take the derivative. All right. So once we take the derivative, again, we're looking for a maximum or minimum. And at this point, 800 minus 16x cubed, or 16x over 3 is our derivative. How did I get that? Well, x has a power of 1. I bring the 1 down. That just leaves me 800. Take this power of 2, bring it down. 2 times 8 is 16. Reduce the power by 1. I get x. And then the 3 stays the same in the denominator. All right. Now that I have the derivative, I want to set it equal to 0. When we do a first derivative, we set it equal to 0, and that helps us find our max or our minimum value. Set equal to 0, we put 16x over 3 on the other side. We can multiply by 3 and then divide by 16, and that will give us 150x. All right, 150 is what x is equal to. So now we have x right here. And now we need to find y. Well, we just substitute the x back into our earlier y equation right here that we had. 400 minus 4x over 3 is equal to y. Substitute my 150 in there, divided by 3, and we get a y value of 200. So now I know that each part of the x, those are all going to be 150, and my y value now will be 200. And so I'm ready to find my maximum area. So let's see. So the maximum area then will be A is equal to 2 times 150 times 200. And so our maximum area is 60,000 yards squared. That's a pretty big area. But we also have 1,200 yards of fencing. So that's almost a mile of fencing, just shy of 1,500 meters. So anyway, hope that helps. Re-review that. Hope you enjoyed that. That's optimization. I'm going to do another one where there's a river bounding by the fencing area. So I'll do that next. Thanks. Have a great day. Keep it mathy. Talk to you soon.